In this video, I'm going to go through how to find the critical path and minimum time needed to complete this project here. So let's go through the beginning of the project. And by the way, this will be up to achieved, and then the merit and excellence will be in the following video or videos. So Proman is a company that specialises in managing building projects. It has been contracted to manage a project to build a new shopping mall in Albany. So this is the project that we're doing. This activity requires you to write a report making recommendations to the manager of Proman regarding allocation of staff to supervise the project, basing your recommendations on a critical path analysis. The quality of your thinking and your ability to identify the impact of unexpected delays will determine the overall grade. Use the information below to prepare a report for the manager of Proman, recommending how they should allocate staff to supervise the building of the new shopping mall. And these are the things that we need to include. Now for achieved, we only need to do network diagram, task in the critical path of the project, and the minimum length of time to complete the project. So that's just achieved. Start and finish time for each task, and the rest of them are for merit and excellence. So we'll go on to that in other videos. We need to clearly communicate our methods using appropriate mathematical statements. And then we've got a table with the short letter for the task, what the task actually is, the duration, so how long the task takes, and what it's preceded by, so what comes before it. Proman will allocate senior staff of the company to supervise each of these tasks. Each person can only supervise one task at a time, and the company is aware that selection of the construction company may take longer than the time allowed in the table due to the competitive tendering process involved. So that will be for merit and excellence. The manager is aware that factors outside their control could lead to delays in the completion of any task, and that there is for excellence. Okay, so let's start this. We need to make a network diagram showing the tasks in the project. So we start with the ones that don't have anything before them. So this one, I'll make that a little bit smaller. This one and this one don't have any before them. So that's A and B, and that takes 5 weeks and 6 weeks. So we start off with that, and we are going to draw little square. Now I'm going to copy this to make my first one, and I'm just going to copy it over a bunch of times for each of my tasks. So copy, paste. Now your network diagram just has to, you can do it from left to right or up to down, but it just has to show the flow of tasks. So what you have to do first, second, third, fourth, and so on. So our first task that I'm going to do is task A, which is prepare drawings. It takes 5 weeks. It doesn't have anything before it, so that's why I can start with it. So that's task A. It takes 5 weeks. And because we're starting at the beginning, if you start timing, you start at 0. So we're starting at 0 weeks, and we're finishing at 5 weeks. So this little table always goes in task, time, earliest start, earliest finish, latest start, and latest finish. You only need these 4 in order to get achieved. So I'm just going to do those 4 in this video. We could also start with B, because it doesn't have anything else before it as well. So I'm going to put it on the same level as A, and then fill that in. So task B, identify tenants, takes 6 weeks, doesn't have anything before it, so that's why you can do it at first. So task B takes 6 weeks, so that's the time. The earliest start, you can start it from day dot, so that is 0, and then you can finish it at 6 weeks. Now that we've done that, we can do these other ones. So anything that has A or B before it, and only A or B, can be started now. So we could do C, because it has A before it, and we've already done A. D, because of the same reason, and E, because of the same reason. So they're all following A. So I go 1, 2, 1 to C and D and E. So that goes there. This goes here, and this goes here. Okay, so we've got C, D, and E. Now C takes 4 weeks, D takes 3 weeks, and E takes 1 week. So we've got 4, 3, and 1. Now since we're starting it after A, that means when A finishes, we can now start these ones. So once that's finished, it finishes at 5, so C, D, and E can all start at 5. But they all take different times, so we've got 4, 3, and 1. So if you start at 5 and it takes 4 weeks, you'd finish at week 9 for C. Start at week 5 takes 3 weeks, you'd finish at week 8. Start at week 5 takes 1 week, you'd finish at week 6. So that's C, D, and E. Now F can go after E. So I'll do a little arrow going down. F. So now, just to clarify, we're looking for everything that can happen after A, B, C, D, or E. So because F, which takes 4 weeks, comes after E, we can do that. We can't do, we could do B after B and C as well. We could do H, because we've done B and C already. But we can't do the other ones because we haven't done F yet and we haven't done G and H. We're doing F now, so we'll be able to do that next. So F takes 4 weeks, and since it's coming after E, it can start when E finishes. So it can start at 6 weeks and finish at 10, because 6 plus 4 is 10. Okay, we can also do a task here, task H, because it comes after B and C. So I'm going to move things around a little bit. I'm going to put B there, because now it's next to C, and it just makes my diagram a little bit prettier, a little bit easier to read. So now this comes after 2 tasks. So that means I've got 2 arrows going to it. So that is task H. It takes 12 weeks. And because it's starting after B and C finish, we cannot start until both of them finish. B finishes at 6 and C finishes at 9. So that means this one has to start after both of those. Both of those have finished at 9 weeks. So this would start at 9 weeks, plus 12 makes 21. That's when it would finish. Like that. Okay, so we've now done H. Now, we have done D and F, so we can do this task here. We can do task G, but we haven't done task G, so we can't do I yet. Okay, so we can do task G. It starts after D and F. So I'm going to narrow down here. we've got task G. Which takes 14 weeks, and it's after D and F, so I've got those two lines there. And because it starts after D and F, it has to start when both of them are finished. So the earliest that this one finishes is 8, but the earliest that this one finishes is 10. So they've only both finished at 10 weeks. So G can start at 10 weeks and finish at 24 weeks. Okay. Now that we've done all of those, we've got our last one, which is I, which comes after G and H, and it takes 2 weeks. So, and I'll just move this over here for my final one. That is I. Now it comes after G and H, so both of them have to have finished. They've both finished at 24, take the bigger number, so it starts at 24. I takes 2 weeks, so it would finish at 26 weeks. Okay. Now, when you're looking at this, you're looking for the minimum time to complete the whole project. So since we've just done earliest start and earliest finish, that means that this earliest finish part will give us the minimum time. So to get all of the projects done, the earliest all of them could finish is at 26 weeks. So that means, let me just type this out. The minimum time to build the shopping mall is 26 weeks. And we've also got to find the critical path. Critical path is, right, so now we'll do that. So the critical path is the things that have to start and finish on time to make sure that this job finishes by 26 weeks. So we have to look at these and look for when do they start and when do they finish, and when is the next task or the end of the project. So looking at this one starts and finish, and the earliest it can finish is 26 weeks, so that has to be a critical task. So you're looking for the ends of the project. So sometimes you have like a dead end in a project. If it's not the earliest finish, then it's not if it's not contributing to the minimum time, if its finish time is not the earliest finish time for the whole project, it is not in the critical path. So I is in the critical path, so we'll highlight that. Now for I to start at to finish at 26, it has to start at 24. So all the projects coming before it have to finish by 24. Now this one, its earliest finish is 24, and it has to finish by that time for this to start on time. So that means that G is in the critical path as well. But H is not, because this could finish at 21, but it only has to finish before 24. So this one's got actually 3 weeks of leeway that it could be delayed, and it still wouldn't delay the end of the task, the end of the whole project. So that means that H is not in the critical path. So we've done everything leading on from I. So now we look at the ones that we've just looked at. So this is not in the critical path. Let's look at this one. And since this one's not in the critical path, because this one only leads on to this, that means that this one's also got 3 weeks leeway, because this one doesn't have to start for another 3 weeks, so that one can finish 3 weeks later and it would still be okay. You'd still finish the whole project on time. Same with this one. This one only leads on to that, and so that means that since this one can start 3 weeks later, this one can finish 3 weeks later. So none of these are in the critical path. But this one has to finish before this one starts, because this one has to start on time. So since this one starts at 10, the ones before it have to finish at 10. And because this is the earliest finish time for this one, 10 is the earliest finish time, that has to start and finish on time for this one to start and finish on time, so that this one can start and finish on time and you'd finish the whole project. Looking at this one just has to finish by 10 because it leads on to 10, but it can finish at 8. So it could finish at 8 or delay until 10 and it would still not impact the whole project. So that one's not in the critical path. Okay, so we've done everything leading on from this, we've done everything leading on from that, we've done everything leading on from that. Now we need to do F. F needs to start at 6, so that means E needs to finish at 6. So this is the earliest it can finish, so it has to finish by that time in order to not delay the project. So this is in the critical path. E needs to start at 5 to finish at 6. So that means that the one before it, A, has to finish at 5 in order for E to start on time. So since this is the earliest finish, A is also in the critical path. So that is our critical path there. A, E, F, G, I. They have to start and finish on time for this project to be completed on time. So the critical path is A, E, F, G, I. If you can draw the network diagram and do this, that is achieved. Thank you for watching. Good luck for the rest of it.